Okay guys, I think I got the microphone working now. So here we go, reflections of functions. So we have a function here. How do I know it's a function? Remember, it passes the vertical line test. It only touches it in one place when I draw a vertical line. So let's pick some points off of here. Let's do the -9, -6. Okay. -5, 8. And notice I'm picking some points where it changes direction. So -2, 8. Next one where it changes direction is at 4, -4. And 10, 2. So when you want to reflect, you need to pick some specific points on your graph. Now, doing a y-axis reflection. So basically, we're flipping the function over the y-axis. So this portion will end up over here. This portion will end up over here. So notice that when this moves over here, the y value doesn't change. Okay, but the x value does change. So if this point is 9 units to the left, now it would be 9 units to the right. So what does that do for our x coordinates? Well, it changes the sign. If it's -9, -6, it'll change to +9, -6. Okay, this point here, -5, 8, would go to +5, 8. So notice the x coordinates. When you go over the y-axis, the x coordinates change their sign. So 2, 8. So what does the positive become? That's right, negative. Remember, the y coordinate does not change. So the rule here for a y-axis reflection from going from a point to the reflected point is the opposite of x, or -x. And then the y coordinate stays the same. And using function notation, this is what it would look like. We're changing all the x, all the inputs, we're multiplying by -1. And then we can graph the new graph. So we got 9, -6, so 9, 5, 8, 2, 8, -4, -4, -10, 2. If I had a straight edge, this might look a little bit nicer, but we'll just stick right here with freehand draw. So notice this is now on from the left side to the right side, and this dip went from the right side to the left side. Okay, x reflection. Well, let's use some common sense. If a y-axis reflection changes the sign of x, what do you think an x-axis reflection does? That's right, Christian. Very good. It would change the sign of the y, because this on top, which is positive, would be flipped over the x-axis, and then the y coordinates would become negative. So the x is going to stay the same. We're going from the original function. So the x stays the same, and your y coordinates are the ones that are going to change. So all of these are going to be multiplied by -1. Okay, so compare that to that. Okay, so the notation here, x stayed the same, and then y got multiplied by -1. And for function notation, the negative would go on the outside of f of x. Remember, f of x represents y, and all the y values are changing their sign. Okay, so let's plot the points here. -9, 6, -5, -8, -2, -8, 4, and 10, -2. Okay, notice this portion on the top is now below. It reflected over the x-axis. This portion on the bottom, everything that was below, is now on top. Okay, next reflection. Reflecting across the origin, or reflecting through the origin. So when we do a reflection through the origin, what happens is the x and the y-axis will change their sign. So we're going to use the rule, change the x and change the y, both of them. So looking back at our original points, okay, all the signs are going to change this time. So x is going to go from, in the original we had 10, 2, so we're going to have -10, -2. In the original we had 4, -4, becomes -4, +4. Notice the signs are changing. In the original we had -2, 8, +2, -8. +5, -8. And finally, 9, 6. Okay, let's see what this looks like. So -10, -2, -4, 4, 2, 8, oops, 2, -8, misspoke, 2, -8, 5, -8, and 9, 6. Now, let's see how this worked. So notice, this up here got reflected over the x and over the y. So it ended up here. This peak, or I should say dip, reflected over the x and over the y, which ends up here. Okay, last reflection, reflecting over the line y equals x. So, ouch, in this case, we already know this, because remember, y equals x is the line of reflection, or the line of symmetry for our inverse functions. And what do we do with x and y for inverse functions? We switch them. So x and y switch. Line of symmetry. So, going back to our original points, we're going to take our original points for our function and we're going to switch x and y. Okay? Y equals x, remember, is our line. Here's our line of symmetry. So let's plot the points quickly. -6, -9. 8, -5. 8, -2. -4, 4. And 2, 10. All right. So notice how it turned our graph sideways, so to speak. So notice on our original, okay, the coordinates changed, so it went from up here in the second quadrant to down here in the fourth quadrant. Okay, notice this was in our first quadrant, and then it went over here into our third quadrant. Actually, my fault. It went from our first quadrant, because it's 10, 2, so it went from 10, 2 to 2, 10. So that ended us up right up here, 2, 10. Okay, so that is our reflection over the line y equals x. And this would be the inverse. And it's actually not a function. It's actually an inverse, in this case, relation, because it doesn't pass the vertical line test, so it is not a function. All right, guys, we'll see you in class tomorrow. Hope you're having a good night.